Okay. Excuse me? Okay. All right. So for those of you that have been exposed to limits, this is just going to be a review for you, but it is actually a very good review. Today we're actually going to be talking about limits. We're going to be looking at graphs as well as tables. So even if you don't have a calculator, you can actually fill this table in if you were using your phone or whatever, and I will be going through these values. But let's talk about the definition. So first of all, if we have our function f of x here, graphically, this is what we have. Whatever that may be, doesn't really matter. What we're looking at is if the values of the function of f of x can be made close to this given value L by taking values of x sufficiently close, okay, to this value a, but not equal to a. So what does that mean? All right, so we're talking about some values getting close to, but not equal to. All right, so we're going from the left side and the right side. That's what we're talking about, approaching from the left and from the right. So if the value that we're looking at for a, right here, is, let's say, 5, this could be 4.99999, or from the other side, 5.00001. But really, a limit is looking at the behavior of the function from both sides. Okay? So what this looks like is the limit, right here, what we're talking about, as x approaches a of our function, whatever it is equal to L. Okay, and one thing that we do need to understand right here is that this L value, it's essentially a y value. Meaning whatever our function is, we're going to plug in that a, which is what we're talking about here, and get a corresponding y value. Okay, so again, the limit of f of x as x approaches a is equal to L. There's so many different ways that you can read this, but this is the notation that you need to be familiar with. Okay, will we always get an answer? No, not always. So the way we look at this first is by looking at one-sided limits, meaning we're taking a look only as we're approaching from one side. Okay? So if we're identifying or taking a look at one-sided limits, what we're looking at is if the values of our function can be made as close as we like to some given L by taking values of x sufficiently close to but greater than a, then we write the notation like this. But the biggest thing that you need to pay attention to is this part. You have that exponent. It's super tiny, so that's why you probably need to look at it on your paper. Let me zoom in just a little bit here. Okay, that exponent is a plus, which means we are evaluating the limit of f of x as x approaches a from the right is equal to some given value L. So we're looking at this limit as we're approaching from the right because this has an exponent that's a plus. Okay? And then the values of f of x can be made as close as we like to L by taking values of x sufficiently close to a, but now we're looking at less than. Okay, so again, the notation looks almost identical, but what we're focusing on is the exponent of what we're approaching for x, and then we would make our statement, okay, that the limit of f of x as x approaches a from the left is equal to L. Okay, so we really do need to pay close attention to that notation. It's super important. Okay, does anyone have any questions about the definition? Okay, because now we're going to talk about how we actually evaluate. We're just going to look at the graph. So here we're given some random graph. Doesn't matter what the function is. This is literally a piecewise function. Okay, so what we want to look at, and these are one-sided limits, is...
Nice.
Yep. All right, so we left off attempting or getting ready to attempt to evaluate the limits given this piecewise function. So what we're looking at here is our piecewise function is a graph. It does not matter what the functions are because we're not going to evaluate these algebraically. We're just taking a look at the graph. So in this case, it says evaluate the limit as x approaches -2 from the left. So here I am at -2, and I have two pieces to this function, but I want to evaluate from the left. So can someone tell me what that value is? Yeah, it's just 1. Okay, so I just put 1. That's it. That's all I have to do. So then here, this is saying evaluate the limit as x approaches -2 from the right. Absolutely. So is it okay that our one-sided limits have different values? Yeah, so even though we haven't evaluated limits overall, does anyone remember what's going to happen when you evaluate the limit as x approaches -2? It doesn't exist. Why? Take a look at what's happening. Yeah, they don't meet up. Okay? There's no, it's not going to happen. Okay? All right, so what I want you to do right now in your, I don't know, you can either do it in your groups or your shoulder partner, talk about and evaluate these one-sided limits together or independently. It's really up to you. All right, so let's just quickly review what these answers are. What did we get for C? Anybody? 1. What about D? 1. E? 0. Yep. F? 3. G? 3-ish, right? If you gave me 3 or 4 or 3.5, that one's kind of ambiguous, right? Yeah? So we would have to accept some answers. I think last year or even the year before, I had kids say 3.8, 3.7. I mean, they were trying to be funny. It's totally fine. And then what's this one? Same value. Whatever you put here, you should put it here. Yeah, so then does this limit overall exist? I know we haven't done that yet, but yep, awesome. Okay, questions on one-sided limits. Okay, so if you understand, for the most part, or are grasping the concept of the one-sided limits, then when we deal with two-sided limits, I'm hoping this is going to be okay for you. So with a two-sided limit, okay, you do need to understand the one-sided limit. So first of all, what the definition states here is that if the limit as x approaches a from the left and the limit as x approaches a from the right of f of x both exist, okay, so they must both exist, and they have to be the same value, so the same number L, then what we're saying is the limit as x approaches a of f of x exists, and it's equal to L. Okay, so the caveat here is they got to be the same, right? They have to be the same value. So if either one-sided limit does not exist, meaning you're saying D and E, okay, or they do both exist, but they're different numbers. They are different numbers. Then the limit overall of f of x as x approaches a does not exist, and we will use the following notation for this, D and E. Okay, D and A and undefined, not necessarily the same thing, because the one-sided limits can exist. It says different. Did you have a question? Sure. So you just need to make sure you use this notation. Okay, so then if both values are the same, you would just say that whatever L is, that's what your limit is equal to. Questions? Are you sure? Okay. So let's take a look at what we've got here. So up at the top, it says that we're going to use this graph to answer the questions. So I'm just going to do one, and you guys can do the other three. We've got the limit as x approaches -5. So the whole idea here is we need to make sure that the limit exists from both sides and it's the same value. So the limit as x is approaching 5. Well, here's where x is 5. Just because there's no dot there, does that mean that the limit doesn't exist? No. I mean, the graph is there, so there's got to be a point, right? Oh, it's -5. I see it. Yep, thanks. The limit as x approaches -5. It's the same idea, though. Thank you. So what is that value? Can anyone tell me? It is 4 because we're looking here. This is not really that ambiguous as the other one on the previous page. So when we're approaching from either side, we get 4. So the answer here is 4. Okay. Question. Let's look at C. The limit as x approaches 0 from the left. What do you get? From the left? 0, but from the right. There is no limit. It doesn't exist. Or you could say what? Anyone know? You could. Well, yeah, you will say DNE here, but if I'm just asking you to evaluate the limit as x approaches 0 from the right, where does it look like it's going? Positive infinity. Okay, we'll talk about limits at infinity later, but the whole idea here is there's a couple different ways that you could answer that part of the question. But then overall, because these two graphs do not meet up, the limit does not exist. Okay, you guys go ahead and do B and D.